Part 1 on photoelectric emission. So, before we go into photoelectric emission, I want to talk about electron emission. Electron emission. Now, from the word itself, we can understand what it means. What is electron? Electrons are negatively charged particles. Okay, and emission means like to release something, right? To send out or release something, often into the atmosphere, right? So what does electron emission mean? It means sending out electrons from a surface into the atmosphere. So we understood what electron emission is. Now why are we learning about it? Okay, suppose we have a surface. Okay, this is a surface, and the surface has many atoms. In those atoms there's many electrons. So these electrons, when there is a trigger, suppose we give some sort of trigger like heat, light, some sort of energy. If we give some sort of energy, electrons will bounce out of this surface, right? Due to this high energy coming, like for example, if the electrons were golf balls and we gave the energy in the form of a bat swing, okay, if we swing the bat, it hits the electrons, which are the golf balls, and goes flying out. So such a representation can be made for electron emission. Electron emission is when some sort of energy is put into the surface such that electrons are emitted from it, and these electrons cannot come without no energy, right? So something is binding them to the surface. That surface binder is called attraction, surface attraction, or the nuclear attraction of the nucleus to the electrons, right? So without the external energy, the electrons won't just go flying out. They are binded to the surface. So to overcome the surface attraction, we have to give some sort of energy. And there's a term for that, the minimum amount of energy that is required. So a certain minimum amount of energy that is required given to an electron to pull it out from the surface of a metal is called the work function of the metal. Okay, so we're talking about metals here because electrons are most easily emitted from metals, because electrons in a metal atom are more loosely bound to the nucleus. I'll tell you what that means. Suppose this is the nucleus. Metal atoms are usually really large. Okay, metal atoms are really large, so this distance is really large. So if this is the electron and this is the nucleus, the distance increases, so therefore the Coulomb's force of attraction decreases, right? So it's easier to eject these electrons because there is less attraction from the nucleus. But for non-metals like chlorine, fluorine and all, if this is the nucleus, they are really small. They're really small. So electrons have a higher attraction to the nucleus. So we generally say about metals, for metals, work function means the minimum amount of energy given to a surface such that an electron is the electron escapes from the metal surface. So the minimum amount of energy for the electron to escape the surface is called work function. So we learnt a term here, that is work function. So every metal has a work function and it depends on the nature of the metal. For example, if this was sodium, metal, and we took aluminum metal is atoms is smaller than sodium, but since it is a metal, it still has way less attraction than the non-metals. So for aluminum, the work function might be greater because attraction is greater. We need more energy to remove this electron. But since sodium is larger, this distance is larger, so electron can be easily removed from the surface using little energy, so its work function will be less than aluminum. So in such cases we can use work function. Work function is denoted by the Greek letter phi, and it's generally measured in EV. We have heard about joules. We measure energy in joules, calories, but we have never heard about EV. EV is one such other unit. 1 EV is equal to 1.6 times 10 raised to minus 19 joules. Okay, we have to know this conversion. If we are gonna do problems related to work function, we should know 1 EV is equal to 1.6 into 10 raised to minus 19 joules. By saying this 10 raised to minus 19 joules, we can see how small an EV is. 10 raised to minus 19 means there will be 0.0000 followed by 18 zeros, 17 zeros before 16 comes. So that's how small a EV is when we are comparing to joule. So in the case of atoms, it's convenient to use EV because they are also very small. So we supply the energy in EV, electron volts, and that will help us get some whole number units. Like if we are supplying 2 EV, this is really easy to read than if we are going to supply 3.2 into 10 raised to minus 19 joule. If we were to say this, it would not make sense. So we just denote as, we just say it in the terms of EV. So 2 EV is equal to 3.2 into 10 raised to minus 19 joule. Right? So we measure work function in EV. We measure other such quantities in EV like threshold energy. We are coming to that, but before that we have to discuss the types of electron emission. We noted that by giving energy we can excite an electron outside this. We can push an electron outside its surface, right? But there are different types of giving the energy. Like we can give it in the form of heat, sometimes sound, sometimes light. So we'll discuss those types of electron emission.